Good morning. I am Reggie, Associate Professor, Department of ECE, Rogni College of Engineering and Technology. Today we are going to see about Unit 4, Analog Digital Transmission System. On completion, students will be able to understand the differences between analog and digital transmission, describe the technique used to send digital data using analog technology. Analog transmission. An analog waveform is characterized by being continuously variable along amplitude and frequency. Analog facilities have limited bandwidth, which means they cannot support high speed data. Another drawback of analog transmission is that noise is accumulated as the signal transfers the network. As the signal moves across the distance, it loses power and becomes impaired by factors such as moisture. By the time the signal arrives at the amplifier, it is not attenuated, it is impaired and noise ending up with high error rates. Digital transmission. Digital transmission is quite different from analog transmission. For one thing, the signal is much simpler. Rather than being continuously variable waveform, it is a series of discrete pulses representing 1 bit and 0 bit. Digital network use regenerative repeaters. The repeaters regenerate the weak and impaired signal to pass on the next point in the network in the essence of eliminating noise and thus vastly improving the array. Analog transmission versus digital transmission. Data continuous, audio versus discrete test. Signaling continuously varying electromagnetic wave versus sequence of pulse voltage. Digital technology. Digital integrity, which refers to the accuracy and consistency of data being transmitted. Repeaters take out cumulative problem in transmission. Transmit longer distance. Easier to multiplex large channel capacity with digital transmission. Easy to apply encryption to digital data. Better integration if all signals are into one form. It is very difficult to integrate voice, video and digital data. So now you can see the basic communication system, which consists of a source encoder, channel encoder, modulator. So these are related to the transmission part, and while you are coming to the receiver, it consists of a demodulator detector, channel decoder, source encoder and destination. So from source to destination, these are all the communication system what we are having. Digital transmission of analog signal. To transmit analog message signal such as voice and video signal by digital means, the signal has to be converted to digital signal. The process is known as analog to digital conversion, or sometimes referred to digital pulse modulation. Two different techniques of analog to digital conversions are pulse code modulation and delta modulation. Digital data bar analog signal. To send digital data using analog technology, the sender generates a carrier signal at some continuous tone, that is 1 to 2 kHz in phone circuit, that look like a sine wave. Resulting bandwidth is sended on the carrier frequency. So analog transmitter and receiver, it is having a information source, transmitter, and again the noise source is added in the receiver to the destination. So if the noise source is added, how we are going to remove the noise? Amplitude shift modulation. Vary the amplitude used to transmit digital data over fiber optic. Frequency shift modulation. Two are used, which is nearer to carrier frequency, used in full duplex modem. Phase shift modulation. Systematically shift the carrier wave at uniformly spaced interval. For instance, the wave should be shifted by 45, 135, 225, 315 degree at each timing mark. In this case, each timing interval carry 2 bit of information. Why not the shift is 0, 90, 180 and 270. Shifting 0 degree means no shift, and extended set of no shift lead to clock synchronization difficulties. Frequency division multiplexes. Divide the frequency spectrum into smaller subchannel, giving inclusive using a subchannel. One problem is FDM is that user is given all the frequency to use and the user has no data to send, bandwidth is wasted. Time division multiplexing. Use time slices to give each user the full bandwidth, but only for the fraction of second at a time. Again, if the user does not have data to slice, the bandwidth is not used. Statistical multiplexing. Allocate bandwidth to arriving packet on demand. This leads to the most efficient use of channel bandwidth because it is a carrier's full data. That is, channel bandwidth is allocated to packet that are waiting for transmission, and a user generating no packet does not use any channel resources. So from the quiz question, you have to understand what is the difference between analog and digital transmission. Describe the technique used to send digital data using analog technology. Thank you.